Hello and welcome back to our channel. I know it's been a long time since you have seen me on this channel talking about Power BI, but I have been busy these last few months working on planning our travel videos, driving to unique destinations near Calgary, and shooting our travel vlogs. I hope you do watch and like our travel videos too. In this video, I am going to share some case study type questions that might come in your Pl300 certification exam for Power BI. I have collected these questions and their explanation from various different resources online. So I hope you can practice these questions, and if you are already prepared to write your exam soon, these questions will definitely help you in revising your concepts. This year we are planning to reach 5000 plus subscribers and hoping to reach 10k subscribers by the end of year 2025. So please, if you do like our videos, hit the like and subscribe button. If you know your friends, family or colleagues who are interested in getting certified in Power BI, CAPM or PMP, or are planning to move to Canada, please share our videos with them. It might help them a lot as we are always trying to upload new videos every other week on these topics. Do let us know if you have any doubts, concerns, questions and suggestions for our channel. You can post them in comment section below and we are always actively replying to your comments whenever possible. So without further delay, let's get started.
So let's start with case study number one. Company 1, which is a pharmaceutical company, develops, manufactures, and supplies healthcare products. Company 1 has annual reporting requirements, including a balance sheet, income statement, and a profit and loss report for the previous year with projections for the current year. The reporting within the financial system is limited and does not meet the company's requirements. Historically, producing these statements and reports has taken a significant manual effort that was error prone, and it has not been possible to perform useful analysis on financial data. So, what are the planned changes? So, Power BI Service and Power BI Desktop will be used to generate financial reports, statements, and analysis for financial data. Data sources: the financial system holds all financial data, including sales and expenses. The finance system holds the chart of accounts. The finance system also stores its data in an open premise SQL server. Sales prediction and budget plans are stored in Excel workbooks in SharePoint Online. Reporting requirements: we need income trend, expenditure trend, comparison of income and expenditure for the current year and previous year, comparison of planned income and expenditure for the next year with current year. What users should be able to do: users should be able to drill down on data by country and territory. They should be able to drill down using the chart of accounts and structure. They should use the Q&A feature of Power BI. What are the security requirements? Well, C-level executives should have access to all analysis, and country and territory managers should only have access to the data for their country and territory. Now let's see what the chart of accounts and expenditure looks like. So that's the chart of accounts table, which has account number, parent account number, account name, account group, account subgroup, financial statements. And in the expenditure table, you have year, account number, and spend. Let's go to the data model. So data model, as you can see, there's an income table, there's an expenditure table and chart of accounts with many to one relationship and many to one relationship with year. The chart of accounts table has relationship with predicted sales with one to many, and chart of accounts also has a relationship with budget with one to many, right? Now the income table has columns like account number, country, territory, 2018 year, 2019 year, and 2020 year. Incomes. For the budget table, we have year column, account number, country, department, and the budget amount. And in predicted sales table, you have year, account number, country, territory, and the forecasted sales. Right? Now let's see what they are asking. So a visualization is created that show the year, department, and forecast sales as shown in the below exhibit. Right? So this is the table. Now, question number one is, which relationship should you configure and how should you configure that relationship to solve the data problem? The relationship to configure, and the second point is how to configure that relationship. To answer, select the appropriate options. So option one is chart of accounts and budget, and then set the cross filter direction to both. Option two is chart of accounts and budget and set the cardinality to 1 to 1. Third option is chart of accounts and predicted sales with set the cardinality to 1, and the fourth option is chart of accounts and predicted sales with set the cross filter direction to both. So what do you think the right answer for this question should be? If you selected option 1, then yes, that's the correct answer. The explanation that they have given is you should configure the relationship between the chart of accounts and budget. The visualization uses data from predicted sales. The department on the budget table is accessed via the relationships on the chart of accounts table. The direction of the relationship between the chart of accounts and budget is a one to many. So if the relationship has a cross filter set to single, the visualization cannot summarize the departments. So if you go back to the table for data model, see, as you can see, chart of accounts with predicted sales, the relationship is one to many, right? So that's why, as well as for budgets, it's one to many, right? One to many, right? So that's why if the cross filter is set to single, the visualization will not work, and that is why you should configure the relationship and set the cross filter direction to both, and that's how you can resolve the data error in the visualization. Now let's move on to question number 2. For the same case study, now you need to create a table containing unique countries and a table of unique combination of countries and territories. Now which DAX expression should you use? To answer, select the appropriate options from the drop down menu. Option 1 is country is equal to values. Under brackets we have predicted sales account number. Territory is equal to summarize predicted sales comma territory comma account number. Next option is country is equal to values. Under bracket we have predicted sales territory. Territory is equal to summarize country comma territory comma account number. Next option that we have is country is equal to data table. In brackets we have predicted sales country. Territory is equal to summarize predicted sales territory country. Fourth option is country is equal to values. Predicted sales country. Territory is equal to summarize predicted sales comma territory country. And the fourth option is country is equal to values predicted sales country. Territory is equal to distinct predicted sales territory comma country. Now which do you think is the right answer? So obviously the fourth answer is correct, which is country is equal to values predicted sales country territory is equal to summarize predicted sales comma territory comma country. And the explanation that they have given is you should use the values function to gather distinct values from another table and populate a new table. The values function generates a one column table of unique values. You should use the country column to create the country table. The country column contains country values. And you should use the summarize function to gather unique combination values from columns in another table and populate a new table. The summarize function groups data. So if you use summarize with two columns, it generates a table of unique combinations of the values in these columns. And you should use country and territory columns when creating the territory table. Now let's move on to a case study, which is case study number 2. Here you see you are a data analyst for a retail organization and you need to show a histogram of the quantity of items in a basket by the size of the basket. A sample set of the data is shown in the below exhibit. Here you have basket ID, the purchase date, the amount, the quantity, and the product name, right? Now what you need to do is you need to create a measure for the count of the quantity column. So question number 1 that we have is how should you create the histogram, and select the appropriate options for the visual fields. So what should be the visual that you need to use for the histogram, and the second thing is the axis on the visual. The options are matrix, clustered column chart, or a scattered plot, and in terms of axis you have either quantity, measure, and group. I'll show you the table again quickly. Alright, Now, are you able to guess the answer? Well, the correct answer is you need to use clustered column chart and group on the axis on the visual. The explanation that they have given is you should choose the clustered column chart visual. A column chart visual in Power BI shows the relationship between two data points, a measure and a dimension. Histogram differs from a normal chart in that it only visualizes a single data point. To create a visualization showing a histogram, you start with either a bar or column chart. You should use the quantity for the value on the visual, and you should create a group for the axis of the histogram. A histogram group data into ranges or buckets and shows how many values are in each bucket, and that's what the question was, right? So you create what was the question? It was you are a data analyst for retail organization and need to show a histogram of quantity of items in a basket by the size of the basket, and that's what the explanation also says, that you should create a group for the axis of histogram, and a histogram groups data into ranges or buckets and show how many values are in each bucket. Creating a group with a number of bins and using the group will show the quantity of the data in a histogram. Now let's move on to case study number 3. Here you have a Power BI dataset that consists of a fact table and the market dimension tables as shown in the exhibit. The fact table has 25,000 records. The market table has 4 records corresponding to the business area: market A, market B, market C, market D. And now you need to create a Power BI report containing the visualizations for this data. So as you can see, we have a category table, you have a category subcategory table, you have a fact table, you have market, country, and segments. And all these are related from many to one, many to one, many to one for market, country, and segment. Whereas category, it's one to many, and for category to subcategory is also one to many. Now you need to configure a Power BI report so that users can only see the data for the business area they belong to, right? Now, which 5 actions should you perform in sequence? To answer, select the appropriate list of actions. Select the dimension table, add a DAX expression to filter the data using market, create the rules in Power BI desktop, publish to Power BI service, assign each user to a role. Option 2 is first you create roles in Power BI desktop, next you select the dimension table, next you add a DAX expression to filter the data using the user principal name, next select the fact table, and finally publish to Power BI service. The third option is first you select the dimension table, second you add expression to filter the data using principal name, third select the fact table, fourth assign each user to a role, fifth publish to Power BI service. And the last option is create roles in Power BI desktop, second select the dimension table, third add a DAX expression to filter the data using market, fourth publish to Power BI service, fifth assign each user to a role. So what is the correct answer as for this question? I can go back and show you the table again, data model again, sorry. Well, the correct answer is fourth one, which is first you create the roles in Power BI desktop, then you select the dimension table, then you add a DAX expression to filter the data using market. Fourth is you publish that Power BI publish it to the Power BI service, and the fifth option is you assign each user to a role. So you should match the explanation that they've given is you should match the filter to business area, market A, B, C, or market D. The DAX filter expression will be written like market A is equal to market A. Then you should publish to Power BI service. You must publish after defining the roles and filters. You cannot assign users to role in Power BI desktop, and you can only assign users to role in a Power BI service. Finally, you should assign each user to a role in Power BI service. Now let's move on to case study number 4. Company A is a manufacturing company that is adopting Power BI for its analytics and insights requirements. Power BI Desktop and Power BI Service will be used to generate reports and dashboards for operations, HR, sales, and finance departments. Management are concerned over access to data and reports, so you need to plan the setup, security, and administration of the Power BI environment. You will run a pilot with sales department to verify your proposed configuration before deploying with other departments. So these are the requirements that are given in a table format. So you have existing environment, which is company A has O365 deployed, company A has Azure AD, and security groups for access control, and Office 365 groups are used for collaboration. In terms of data sources, you have Excel spreadsheets, you have other data sources that will be used for pilot, which is SQL, SharePoint lists, JSON files, and Zendesk. For report development, there is a team of business intelligence analysts who will create the report and dashboard. The team will load, transform, and cleanse the data. They will then model the data and create data sets for use across the organization. Changes made by developers should automatically be deployed to users. In terms of security requirements, developers should not have access to production data. Obviously, developers should not have access to reports and dashboards in production. Business users should not have access to developer data or assets. Board members must be able to access sales and reports and dashboards. Excel files used in reports should only be accessible from their workspace. Users must only have access to the data in their department. Users in sales department must only have access to the data in their territory. The report and dashboards for a department should only be accessible by business users in the same department. Business users should not be able to edit the reports and dashboards, and business users should not be able to create new reports or dashboards. And board members are not part of the company network, so they are on a separate network or a different network altogether. Now, the question number one is, how should you configure Power BI Workspace to meet the security requirements for management of reports and dashboards? Option 1 is create a workspace for development, create a deployment pipeline, and assign the development workspace to development stage. Define data source rules and deploy to test and production. Option 2 is create separate workspaces for development and production, share a dataset from developer workspace to the production workspace, create reports and dashboards in production workspace. Fourth option is create a single workspace, publish an app for business users. And option number 4 is create a single workspace, share the reports and dashboards with business users. Let me go back to the requirements so that you can have an idea. Now, what do you think the answer for this question should be? Well, the right answer is create a workspace for development, create a deployment pipeline, and assign the development workspace to the development stage. Next, define data source rules and deploy to test and production. So what's the explanation that is given? So when you create a deployment pipeline and select a workspace, Power BI automatically creates the other two environments, which is testing and production, when you deploy your content. Each workspace in the pipeline has different users, so developers will not have access to the assets in the testing or production workspace, but you can define the dataset and data source rules to change the data source for each workspace. This will remove the need for developers to require access to production data, and deployment pipelines require Power BI premium capacity. The Power BI admin defines which pipeline stages are available. You should not have single workspace and publish an app. An app is then a part of the workspace it is published from. By publishing an app, the developers will have access to the reports and dashboards, and there will be no separation between the developers and production data. So that is why this solution perfectly fits the requirement and the question. Now let's move on to question number 2 for the same case study. Now you need to create a workspace for report development. What should you add when creating the workspace? The PBIX file containing the dataset, the name of an Office 365 group, the name of an Azure AD security group, or the URL of a OneDrive location. The correct answer is the name of an Office 365 group. The explanation that they have given is when creating a workspace, you can specify the workspace OneDrive feature. When setting the workspace OneDrive, you must add the name of an Office 365 group. When you enter a valid name of an Office 365 group, the group is added as the workspace location for shared files. You will use the files area in the Office 365 group to store the Excel files that will be used in the workspace to populate the dataset. You should not use the name of the Azure Active Directory security group. Azure AD security groups are not linked to Power BI service. Now let's move on to question number 3 for the same case study. How should you provide access for board members? So remember in the requirements that we have for board members is that board members are not part of the company network, right? But board members must be able to access select reports and dashboards. So how will you give them access? That's the question. The options available are publish the reports to the web and publish to the web, create an app and share it to the board member email addresses, add board members as users to Office 365 and add users to the workspace, add board members as guests in Azure AD B2B, create an app and invite the guest users. So can you guess the right answer? The right answer is add the board members as guests in Azure AD B2B, create an app and then invite the guest users. So obviously you need to add these guests in Azure AD. What's the explanation given? They have given that you should create the board members in Azure Active Directory B2B. B2B guest users can be invited to use an app and can access the app's selected reports and dashboards. And this is a recommended method for providing access to Power BI content for external users. You should not add board members as users to Office 365 and add users to the workspace. Workspaces are used for collaboration and building reports. Workspaces are not a good experience for end users. Board members are external to the organization and having an organization email address to access the report is also not recommended. Now let's move on to question number 4 for the same case study. What are the two possible ways to control the access to the data in the sales department? Each correct answer presents a complete solution. So what were the requirements for the sales department? If I go back to the case study, users in sales department must only have access to the data in their territory. So that's the specific requirement that they have, right? So let's see how we can answer that question. The options that are available are create workspace for each territory and assign users in each territory to the member role. Option 2 is publish the app from sales workspace and set allow all users to connect to the app underlying datasets using the build permission. Option 3 is publish the app from sales workspace and add users in sales department to the app. And option number 4 is assign the viewer role in sales workspace to the users in sales department. What do you think the right answer should be? Well, option number 3 and 4, which is publish the app from sales workspace and add users in the sales department of the app, or option number 4, which is assign the viewer role in sales workspace to the users in sales department. So the explanation that they have given is to control access to the data as specified in the security requirements, you will need to configure row level security in the dataset. A row level security will be added to users who are assigned the viewer role in the workspace. Viewers can only consume the reports and the dashboards, and there is one of the two solutions that meets the goal. Now, row level security is also applied if the workspace is published as an app. So you should contribute the app to the required end users, and the users do not need to be assigned a role in the workspace and will only be able to use the reports and dashboards in the app. This solution also meets the goal. Now let's move on to the case study number 5. You work for a company that uses Power BI for financial reporting. Analysis and insights for sales are now required. So existing requirement is Power BI services used and workspaces have been created. Power BI desktop is installed. Data sources, you have sales data is stored in Azure SQL database, dimension data for territory and countries held in an Excel workbook in SharePoint Online. Sales schema, the schema for sales data is shown in the schema exhibit. Product ID are alphanumeric and consist of 3 letters followed by 3 numbers. The sales amount is net of any taxes. The tax rate is 20% on all sales. The territory workbook, the data for territory is shown in the territory workbook exhibit, which we'll see next. So what are the observation in terms of issues? So you observe that labels for country are not consistent for territories. The labels used are not commonly used names in your company. The labels do not follow naming corporate standards with capitalization, no special characters and no abbreviations. Users must be able to analyze sales report by product type. The tax amount on sales must be available in visualizations. Sales managers are unable to create visualizations for sales group by product type. Sales managers must only be able to see sales for their territory. So this is the sales schema and this is the territory table. So here you have sales with column name as order number, date key, customer ID amount, product ID, and data type is whole number, date time, whole number, decimal number, text. For customer table you have customer ID, name, salesperson, territory ID. For territory table you have territory ID, name, country name, manager sales. Product ID, you have product ID, product name, product type ID, and product type has product type ID and type name, just the name. And in territory table you have territory ID, name such as South England, North England, Jutland, Zealand, etc., and country name, right? Country name is also, as you can see, it's not consistent. Somewhere it's UK, otherwise it's United Kingdom, right? Somewhere it has written USA, somewhere it's US, and others it's United States. So there is a lot of inconsistency in the territory table. Now, question number one is you need to create the relationship to support the sales manager's visualizations. What should you do before creating that relationship? So options are change the data type of sales product ID to a whole number, create a measure for sum of sales amount, change the data type of product type ID to a whole number, add a transformation to add a calculated column to extract the numeric value for product ID. Well, the right answer for this question is change the data type of product type ID to a whole number. And the explanation that they have given is you should change the data type of product type ID to a whole number. Data type on the fields that are used in the relationship must have the same data type. An incorrect data type will prevent you from deriving hierarchies or creating proper relationship between the tables. To analyze sales by product type, you need a relationship between the sales and product tables. The product ID is a text field in both tables. You additionally need a relationship between the product and product type tables. The product type ID is a whole number in product type but a text field in product. And you need to change the data type of the field in the product to match the data type in product type, right? Because as you can see, the product type ID in the product table is text, whereas the in product type the product type ID is a whole number. So that's why we need to change that. Now let's move on to question number case study number 6. Your colleagues works with a data model to analyze performance of companies offline stores. So he creates a KPI visual to compare how the revenue in the current quarter compares to the revenue from the previous quarter. The below representation shows the measure fields used to build the KPI visual. But there is something off with this visual. The KPI displays a higher value of 33859 than the goal, which is revenue last quarter. But you cannot observe this behavior in the trend chart in the background, which is continuously decreasing in each quarter, as you can see here. Right? Now, to debug this issue, you check the underlying data for the visual. So, what could be wrong with the visual? The note that they have given is offline store revenue table contains historical at least 4 years of revenue data for companies offline stores. Number two that they have given is revenue last quarter is equal to if is blank total revenue comma blank comma calculate total revenue previous quarter date, right? So if the revenue is blank, you need to the formula is that it calculates the total revenue from the previous quarter. Now let's move on to the second part of this case study. where you have options. The options are using the field quarter in the trend axis. Well, is incorrect since many years of data are available. Option 2 is the usage of fields in the indicator with the target goal wells is incorrect. They should be swapped. The total revenue value is much higher than the target because it evaluates total revenue across all quarters. And option number 4 is there is some issue with the revenue last quarter measured used in target goals. Well, since it displays a very low value. So I'll move to the previous screen and show you the graphics again and the question as well. So can you guess the right answer for this? The right answer is option number 1. Using the field quarter in the trend axis, well, is incorrect since many years of data is available, right? So quarter in the trend axis should not be here. And this is the formula that you need to use. You need to use year quarter and the format should be date with y minus q. The explanation that they have given is since the offline store revenue table contains 4 years worth of data, using the quarter field in the trend axis computes cumulatively quarter revenue across all 4 years. That's why we have only 4 plotted values in the trend chart. This is unhelpful because the visual doesn't display how the revenue changes across different quarters. Trend is not meaningful. More importantly, it also doesn't display the current quarter revenue. The discrepancy in the chart is explained by the fact that there is no meaningful comparison between the current and the previous quarter. Revenue last quarter displays value for a specific quarter versus cumulative value for total revenue. The solution is to create a new column that can uniquely identify a quarter across many years. And if you use the format function to format a column with year and quarter combination.